Hello students, so the question is match list 1 with list 2. So list 1 is number A is torque, number B is stress, number C is latent heat and number D is power. Okay, so basically we have to find the SI units for these 4 given quantities. So first taking up with torque is given as tau, which is equal to R cross F vector. Okay, and if I talk about the magnitude, then torque is given as mod of R mod of F sine theta. Okay, so from here I can see that torque is depending on R and on force F. Okay, and the SI unit for R will be meter and for force it will be newtons. So for torque I can say the SI unit will be in Newton meter. Okay, and the next quantity is stress. So stress is given as force upon area, and force is Newton and area is meter square. So the unit for stress will be Newton per meter square. Okay, next is latent heat. Latent heat is represented as L. Latent heat is represented by L, and it is if I go into the relation, then I can write energy is equal to mass into latent heat, and unit for energy is joule. So J here and mass is kg and into L. So for L it will be joule per kg. Joule per kg. Last is power. For power we can write, see, power is given as energy or work done, work upon time, which can be written as force into velocity, vector. Okay, in vector form it is force vector in dot velocity vector. So force is given as Newton and velocity is meter per second. Okay, so this unit can be written as Newton meter per second. So torque is Newton meter. So Newton meter is here, so torque goes with third one. Next is stress. Stress was Newton meter square, Newton per meter square, fourth option. Last third is latent heat. Latent heat was joule per kg, second option, so second will be here. And last is Newton meter per second, so option 1. So this will be the correct arrangement. Looking on the options, it is option B. Okay, option B is right. Thank you. Hello students, so the question is, if V is speed, R is radius and G is acceleration due to gravity, which of the following is dimensionless? Okay, so we have to find the which of the following option is dimensionless. First option is V is, first of all, if I write the dimensions, V is speed, so dimension of V will be M, dimension of V will be LT minus 1. Next is R is radius, so its dimension is L, and G is acceleration due to gravity, so dimension is LT minus 2. Okay, so equating these dimensions in the first one is V square, so I can write LT minus 1 square into R, which is L, divided by G, that is LT minus 2. Okay, so L square, it is L cube T minus 2 divided by LT minus 2. So it is LT minus 2 and T minus 2 will cancel out. I get L square, which is not dimensionless. Okay, next option is option 2. V square G divided by R. This is L square T minus 2 into LT minus 2 divided by L. So L and L cancel out, L square T minus 4, which is again not dimensionless. Third is V square upon RG. I get L square T minus 2 and L into LT minus 2. Okay, if I check this is dimensionless. Okay, So our third option is correct. Checking the fourth one. See, fourth one is logically fourth one is not dimensionless, because whatever can cancel out, but we will get the length in a dimension. In our dimension, length will be there, okay, because all the terms are in multiplication, so no length term will cancel out. So net dimension must include L as its term, okay. So fourth one is also incorrect, so option 3 is correct. Thank you. Hello students, so the question is, in a Vernier caliper of least count 0.1 mm and zero error is minus 0.3 mm, the reading of the diameter of sphere on the main scale is 6 mm and fifth division of the Vernier scale coincides with one of the main scale division. Okay, so the correct diameter is, see, reading is given as main scale reading plus Vernier scale reading minus error, or we can say zero error. Okay, this is the format of writing a reading. Okay, so main scale reading is 6 mm. Vernier scale reading will be, see, least count is 0.1 and fifth division of the Vernier scale coincide with the main scale. So Vernier scale reading will be 5 into 0.1, okay, mm, minus error is minus 0.03, so I can write 0.03, negative of 0.03 mm. Okay, so this will be 6, this is plus 0.5 plus 0.3, which is equal to 6.8 mm. 6.8 mm. So option 4 is correct. Thank you.
The next one is, acceleration time graph of a particle is as shown in the diagram. Acceleration versus time graph. If particles start with velocity of u equal to 2.4 meter per second, that is, initial velocity is given as 2.4 meter per second, then its velocity at t equal to 8 second. T equal to 8 second, we have to calculate the velocity. Now this is AT graph. Now if there is a curve between y and x, and what will be area enclosed? It is integral y dx. And if there is a graph between y and x, then the slope is equals to dy by dx. They are very important. Both the things are very important. Okay. Now this is AT graph. So area enclosed by AT graph will be integral y dx, so it will be integral a dt. Good. Now a is what? dv by dt into dt. This dt cancel out, so it is integral dv, and that is equal to v minus u. That is, area enclosed by AT graph will give you the change in the velocity. That is equals to change in velocity. Got it? So first calculate the area. Okay, this is the area. This area is how much? Length into width. So 0.6 multiplied by 2 plus, calculate this triangle, that is half. Base is how much? 2 to 4 is 2, and the height is how much? 0.2 plus this rectangle, that is 0.4 into 2 plus this rectangle, that is length into width, that is 0.4 into 4. This is the total area. Now 2 cancel 2. So area is equals to 0.6 multiplied by 2 is 1.2 plus 0.2 plus 0.8 plus 1.6. Now 1.6 and 1.2 is 2.8, and this is 2.2 plus 0.8 is 1, that is 3.8 is the area enclosed, and that should be equal to v minus u. Now u is given as 2.4, that is 3.8 is equals to v minus 2.4. So v comes out to be 3.8 plus 2.4. that comes out to be how much? 2, 1, it is 6. 6.2 meter per second. That will be the velocity at the end of the, or at, not end of, at t equal to 8 seconds. 6.2, that is option number 3rd is the correct answer. Got it? It is very important to know that area enclosed by acceleration time graph will not give the change in, will not give the velocity only, it will give us the change in the velocity. Got it? So our answer is option number 3rd. Now comes the next one. With what minimum acceleration can a fireman slides down a rope while the braking strength of the rope is 2/3 of his weight? Okay, that is we have to calculate the minimum acceleration can a fireman slides so that he can come down by using a rope which is having the strength of 2/3 of his weight. That is, the strength is less than his weight. That is, he cannot place his whole weight on the string. Otherwise, instead of coming down, he'll go up finally, and he remains there only. You're getting this? Okay. Now, this is the rope, and here is the fireman. Okay. His weight is mg, acting vertically downward, and he's taking the support. But support is not complete support. That is, he is not putting his whole weight on this. Okay, and this, because of this, he is taking the support. Why I am using the term support? Because he is taking the support so that he will not fall freely. Because if he will fall freely, then ultimately he will become free and he will go up to the heaven. Okay. So tension is acting like this, and tension can be equal to 2/3 times of mg. This is the braking strength. That is the maximum tension can be this much. Maximum T max I should write. And let's suppose he is moving with acceleration A, and we have to calculate this acceleration A. So net force in the direction of motion. Net force in the direction of motion equal to mass into acceleration. Now net force in the direction of motion, that is downward direction, the direction of motion. So mg downward minus T upward or T max is equals to ma. So mg minus tension is 2/3 of mg equal to ma. M will cancel out. That is, A is equals to g minus 2g/3. That is 3g minus 2g/3. So acceleration comes out to be g/3. So g/3 is that minimum acceleration he can come down. Option number 3rd, g/3. A good problem. Moving to the next one. If the system shown in the figure is released from rest, then the speed of 6 kilogram block after 5 seconds. 6 kilogram block after 5 seconds we have to calculate velocity. Okay. First we calculate the acceleration. As you releases the system, this will go down with acceleration A and this will go up with acceleration A. So we can write the expression of A as acceleration we can write directly. Okay, 6g here and 4g here. Both tries to move the system in their own direction. So the acceleration is net force responsible for motion, that is 6g minus 4g upon total mass 6 plus 4. That is equals to 2g upon 10. That is A is equals to g/5. That is equals to 2 meter per second square. Okay, I am taking g as 10. So acceleration is this. Now acceleration is constant, that is equation of motion are applicable. So using first equation of motion, v is equal to u plus at. Now it releases from rest, so u equal to 0. V is equals to A is 2 and T is 5. That is 10 meter per second. So the velocity of 6 kilogram block after 5 seconds will be 10 meter per second. That is option number 4 is the correct answer.
Hello guys, let us solve this question. The velocity and acceleration vector of a particle undergoing the circular motion, it is v equals to 2 I cap meter per second. Okay. and A is what? It is of 2ik plus 4j respectively at an instant of time. At any instant, let particle move on circular path, its velocity is v. Now velocity is 2ik. Now here is 2ik. When particle move on circular path, then that should we have an acceleration towards the center, and which is the perpendicular to the velocity. Okay, and in the direction of the velocity, this acceleration is tangential acceleration and this acceleration is the centripetal acceleration. So here acceleration is what? It is of 2ik plus 4j. Now the radius of the circle is, okay, as we know, along to the direction of velocity, this acceleration will be tangential acceleration and this acceleration will be centripetal acceleration, because of this one is perpendicular to the velocity. So AC is what? It is 4, and we are know that AC is what? It is of v square by r. So radius of circular path, that is r equals to v square by 4. Now v is what? It is of 2 to the square is 4 upon 4. So it will be 1 meter. So correct answer is 1 meter. Okay. Thank you very much.
The next one is a 2 kilogram mass lying on a table is displaced in the horizontal direction through 50 centimeter. Work done by the normal reaction will be. Okay. So this is the table and a block of mass 2 kilogram is placed like this. Okay, it is displaced horizontally from this position to this position, 2 kilogram, and is displaced by 50 centimeter. Now normal, this is 2g, okay, and this is the normal reaction n, that is equal to 2g. Now work done is equal to F dot S, or it is Fs cos theta. Theta is the angle between F and S. Okay, F and S. Now here, normal reaction and displacement are mutually perpendicular. This is the direction of normal reaction and this is the direction of the displacement. So the angle between them is 90. So work is equals to F is how much? 2g. S is how much? 50 centimeter, that is 0.5 meter, into cos 90. Cos 90 is 0, so work will be 0. No work is performed by the normal reaction, and this is a very common example is being given when you study this work per energy chapter in class 11. Example of coolie, that is work, how much work performed by the coolie when he takes your luggage from one position and drop at the another position. Okay, that is 0 because he push the luggage in this direction like this, and he is walking in the forward direction. So the force exerted by him or the mg and the displacement are mutually perpendicular. Got it? So this is same, normal reaction perform, no work. Option number 1 is the correct answer. The next one is 3 rings, each of mass capital M and radius R, are arranged as shown in the figure. Okay, 3 rings. The moment of inertia of the system about YY dash. Okay, now this axis lies in the plane of the ring. All the rings are placed like this, and this axis YY dash lying in the plane of the ring. Now for this is ring number 1, this is 2, and this is 3. Now for ring number 1, this axis is a diametric axis. And for ring number 2 and 3, this axis is a tangential. Just look at this here. For 2 and 3, this YY dash is the tangential axis lying in the plane of the ring. Okay, like this. This is the second, and this is the YY dash. Y dash, Y. Got it? Now about this, moment of inertia is about diametric axis. About diametric axis MI of ring about diametric axis is equals to mr square by 2. Okay, so I about y dash, I'll write the moment of inertia of this system in sequence. First I'll write for 1, then 2, then 3. So for first, it is diametric axis, so mr square by 2 plus. Now to write the moment of inertia of second and third, I have to use parallel axis theorem. This is the diametric axis, moment of inertia is mr square by 2. This is equal to ICM. And this is the perpendicular distance between the diametric axis and y dash. And their perpendicular distance is r. Okay. So for second it is ICM plus md square. And for second and third it is same, so I am multiplying it by 2. What? So I about y dash is equals to mr square by 2 plus 2. Now ICM is mr square by 2 plus m, d is equals to r, mr square. Okay. So it is mr square by 2 plus mr square plus 2 mr square. So it is 3 mr square plus mr square by 2. So it comes out to be 6 mr square plus mr square by 2, that is 7 mr square by 2. 7 mr square by 2, that is option number 4. Option number 4 is the correct answer. 7 mr square by 2 is the moment of inertia of this system about the axis y dash. Got it?
Okay, so the question says that a door which is 1.6 meter wide requires a force of 1 Newton to be applied at the free end to open or close it. The force that is required at a point 0.4 meter distance from the hinges for opening or closing the door is how much? Now, in this particular case, let us first talk about the door. Now, how does a door look like? Door is having a certain axis of rotation about which the particular door rotates, right? So the particular door rotates about this axis. Now, when this is the axis of rotation, if I view it from the top, can I say the axis of rotation would just merely be a point for me which is coming outside the plane, and the door would look like this, right? Now the door is 1.6 meter wide, so the length of this door is 1.6 meter, and the question says that force of 1 Newton to be applied at the free end to open it, right? So if I talk about the force at the free end, it is 1 Newton. Okay, so this torque opens the door. So torque about point O, which opens the door, is 1.6 into 1, which gives me 1.6 Newton meter. Now the question wants us to calculate the value of force when the distance from the axis of rotation is 0.4 meter. If it is 0.4 meter, how will you solve this? You would say, considering the axis as this and the door as this, which is 1.6 meter, at 0.4 meters, we have a force that is being acted on. So this force, let us say, is F. And we basically need to calculate how much is the force such that the door opens. So to open the door, the torque required is already calculated as 1.6 Newton meter. So can I say, if this is my point O, torque about O is F into 0.4, of which this is 1.6, this is F, this is 0.4. Now can I cancel out this with 4? So the value of F is coming out to be 4 Newton. And I hope each and every one of you have understood how we have done the process and calculated the final answer as 4 Newton. Now once you have calculated this, let us match the answer that we have got with the options given in the question. Now looking at the options, I would say the first is wrong, the second is wrong, the third is wrong, but the fourth one is correct. So the final answer for this particular question comes out to be option 4, which is having 4 Newton as the final answer. I hope each and every one of you have understood the question as well as the concept behind this particular question and the solution and the explanation provided to you. Thank you.
The next one is a mass of 20 kilogram moving with a speed of 10 meter per second collide with another stationary mass of 5 kilogram. Okay, as a result of collision, the two masses stick together. The kinetic energy of the composite mass will be, okay, after the collision, both the bodies stick together, that is the collision is perfectly inelastic, because in inelastic collision, both the bodies stick together after collision and move together with the same velocity. Okay, that is perfectly inelastic collision. Okay, so I'm drawing the figure first. Mass is 20 kilogram, moving with a velocity of 10 meter per second. This another body of mass 5 kilogram, not moving with any velocity. And after collision, mass is 25 kilogram because both the bodies stick together, and let's suppose they are moving with velocity v dash. Good. Now this is before collision. And this is after collision. Good. Now, whatever the type of collision, whether perfectly elastic, inelastic or perfectly inelastic, momentum of the system remains constant or conserved. Okay. So, P initial is equals to P final. Okay. Let's suppose V dash is the velocity of the composite mass, V dash. Okay. So, I am writing the initial momentum, that is before collision, equal to final. So 20 into 10 plus 5 into 0 is equals to 25 into V dash. Got it? So this is 0. So it is 200 is equals to 25 into V dash. So V dash is 200 by 25, which comes out to be 8 meter per second. So the velocity of the composite mass after collision is 8 meter per second. The question is asking the kinetic energy of this 25 kilogram after the collision. So the kinetic energy is equal to half. Mass is how much? 25. Velocity is how much? 8. This will be the kinetic energy. Got it? So it is 1 by 2 into 25. It is 64. This is 32. Now 32 into 25. Okay. Now here I am doing the calculation. 32 into 25 is 0, 1, 4, 6. 0, 0, it is 8. That comes out to be 800 joule. So the kinetic energy of the composite mass after perfectly inelastic collision is 800 joule. That is option number 2 is the correct answer. Got it? Now the next one is a solid sphere is rotating about a diameter at an angular velocity omega. Okay. If it cools so that its radius reduces to 1 by nth of its original value, its angular velocity becomes, okay, that is on decreasing the temperature, it cool off, so the radius decreases by 1 nth. Okay. So the question is asking the new angular velocity. As you reduce the temperature, and because of which sphere shrinks, there is no external force or no external torque acted on the sphere. Oh, this is sphere. This is the diametric axis. It is rotating with angular velocity omega. Okay. Let's suppose it has initial radius of r. Okay. So, and now it shrinks. Now rotating about same axis, but its radius becomes r by n. Okay. Now the question is asking the new angular velocity. Now there is no, this is 1, this is 2. Okay, no external torque acted on the system. So external torque equal to 0. And if external torque is equals to 0, that is angular momentum of the body will be constant or conserved. So L of system will be constant or conserved, that is L1 should be equal to L2. This corresponds to 1 and this corresponds to 2. That is, here the bodies are rotating, so we'll write the expression for angular momentum as I omega, not mvr. Okay, so I omega, that is I1 omega 1 is equals to I2 omega 2. Good. Now for solid sphere, moment of inertia is 2 by 5 mr square. So it is 2 by 5 m r square. Angular velocity is given as omega. Now radius becomes r by n. Okay, so angular momentum, moment of inertia is 2 by 5. Now in shrinking, mass remains same, so m, but r by n whole square into omega dash. Got it? Now 2 by 5 m, 2 by 5 m. So it is r square omega is equals to r square by n square omega dash. R square will cancel this r square. That is omega dash is equals to n square omega. So the new angular velocity will increase by n square times. So option number 4. Option number 4 is the correct answer. A very simple question based on the conservation of angular momentum. So the answer is option number 4, that is n square omega is the new angular velocity of the sphere.
Hello guys, let us solve this question. Now this question is on a statement. So statement 1 is, on decreasing the distance between two masses, the potential energy decreases. As we know, potential energy is what? It is of minus g m1 m2 upon r. Now whenever r is decreased, r is distance between the masses, so potential energy will be increased in negative value. Okay. Now here is potential energy decreases. Now potential energy will decreases whenever r is decreases. Okay. Now second statement is, the value of universal gravitational constant g depend upon the acceleration of the two bodies. Now g is universal constant, g is independent of any quantity, not depend. So statement 1 is correct because of u is decreases. U is increases. Okay, here is potential energy magnitude is decreased, but in negative value. Now when r is decreases, u is increases in negative value. U is increases in negative value. So u is what? Actually potential energy decreases. So first option is correct, but second option is wrong. So here is statement 1 is correct. Statement 1 is correct and statement 2 is incorrect. So our answer will be number 2. Okay guys, thank you very much.
The next one is, a mass at end of a spring executes harmonic motion about an equilibrium position with an amplitude A. Okay. Its speed as it passes through the equilibrium position is V. Okay. If extended to A and released, the speed of the mass passing through the equilibrium position will be. Okay. So the question based on simple harmonic motion, and when the particle passes the equilibrium position, it has maximum velocity. Okay. So velocity in harmonic motion, velocity in harmonic motion is given as V is equals to omega under root of A square minus x square. Okay, and x is the distance or the separation from the equilibrium position. Now at equilibrium position, equilibrium position, x equal to 0. So V is equals to A omega. Got it? Given in the question. Now the question is saying, now it is extended up to 2A. So V dash is equals to 2A into omega. Omega will remain same. Angular frequency does not depend on this extension or this. Okay. So this V dash is equals to 2 times of A omega. So V dash is equals to 2V because A omega is V. Okay. So now the mass will pass from the equilibrium position with twice the velocity. 2V, that is option number 1 is the correct answer. Now move to the next one. A simple pendulum has time period T1. Okay. The point of suspension is now moved upward according to the equation y equal to at, where a is 2 meter per second. Okay. If the new time period is T2, then the ratio of T1 square by T2 square is. Okay. So first of all, time period of simple pendulum. That is given as T1, it is 2 pi under root of L by G. Rather, I should write it as G effective. Okay. This is first given. Now, this is the simple pendulum. Now, this point of suspension, this is point of suspension. Point of suspension, POS is point of suspension. Now, start moving upward with the equation according to y is equals to AT. So y is given as displacement. Now y is equals to AT, A is constant. So we can calculate the velocity, dv by dt. That is A. And acceleration is dv by dt. Or it is d2y by dt square and comes out to be 0 because the differentiation of constant is 0. That is acceleration is 0. So this point of suspension is moving with constant velocity. Constant velocity. That is acceleration is 0. So the G effective remains as G. So T2, okay, I am writing here T1, 2 pi under root of L by G. Okay, rather this is equation number 1. Okay. Now T2 is equals to 2 pi under root of L by G only because there is no acceleration. If this A comes out to be non-zero, then effective acceleration will change. But as A comes out to be 0, so G effective remains as G, that is acceleration due to gravity. So T1 comes out to be T2. So T1 square by T2 square comes out to be 1 by 1. So it is 1 by 1. Option number 3rd. Option number 3rd is our correct answer. Got it?
Hello students, the question is two waves of wavelength we have given 99 centimeter and 100 centimeter, both traveling with the velocity 396 meter per second, are made to interference. The number of beat produced by them per second is. So it is talking about number of beat. So if I am talking about students, number of beats, it's calculated by F1 minus F2. F1 and F2 is the frequencies, and we know that the frequency is speed by wavelength. Frequency is speed by wavelength. That means F1 is written as frequency divided by lambda 1 minus this one is frequency divided by lambda 2. So frequency we have taken common. So this one is 1 by lambda 1 minus 1 by lambda 2. So here frequency we have sorry, this is velocity actually, not frequency. Frequency we have put the value. So this one is v by lambda 1 minus v by lambda 2. So we have put the values. So velocity we have given, this is 396 meter per second square, and wavelength we have given lambda 1 is 0.99 meter and lambda 2 is 1 meter. So this one is 0.99 minus 396 divided by 1. Okay, now we have checked the answer. So here if we solve it, so after solving that this beats is comes, this one is 4. This is 4. So here we can say the answer of this question is, we can say here answer of this question is option number 3, which is 4 is correct answer.
The next one is, two vessels separately contains two ideal gas A and B at the same temperature. Okay. Pressure of A is being twice that of B. Under such condition, density of A is found to be 1.5 times the density of B. The ratio of the molecular weight of A and B is. Okay. Two vessels separately contains ideal gas A and ideal gas B. Okay. Temperature is same. Pressure of A is twice that of B. So here pressure is B, pressure is P, here pressure is 2P. Okay, density of A is, here density is rho, here density is 1.5 rho. Okay. Two vessels separately contain, okay. The question is asking MWA by MWB, that is molecular weight, okay, of A by molecular weight of B. But the volume is not, nothing has been said about the volume. Okay. Now from ideal gas equation. From ideal gas equation, PV is equals to nRT. Now, N is number of moles. Now we can write the number of moles as mass upon molecular weight into RT. So P is equals to M by V, RT by molecular weight. Now M by V is density, so P is equals to rho RT by molecular weight. Got it? So MW can be written as rho RT by P. Got it? This is how we can write the molecular weight. So MW for A is equal to rho is 1.5 rho, R is R, T is T, and pressure is 2P. Hold it. MW, that is molecular weight for B, is equal to density is how much? Rho, R, T is same for both, and the pressure is P only, P. Divide them, because this is what the question is asking. Now rho RT, P and P, all are cancelled. So MWA by MWB is equals to 1.5 by 2. That 1.5 is 3 by 2 into 2, that is 3 by 4. So the ratio of the molecular weight of A and molecular weight of B is 3 by 4. So 3 by 4 is the correct answer. Got a good question based on the equation of ideal gas. Got?
Hello students, the question is, two Carnot engine A and B are operated in series. Now engine A receive heat from a reservoir at 600 Kelvin and rejects heats to a reservoir at temperature T. Now engine B receive heat rejected by engine A. That means the temperature T is received by engine B, and its turn rejects to a reservoir at 100 Kelvin. Now if the efficiency of the two engines A and B are respected by eta 1 and eta 2, find the ratio of eta B by eta A. What? Eta B by eta A. So here, if I am talking about the efficiency of Carnot engine A, so efficiency of engine A is calculated by eta A is equals to 1 minus T2 by T1, and here T2 is T and T1 is given as 600 Kelvin. So here this one is 1 minus T upon 600. This is eta A. Now this is equation 1. If I am talking about for B engine, so here we can say efficiency of B engine, efficiency of engine B is, this is eta B is equals to 1 minus, again this is T2, but in case of T2, this one is T2 is 100, because of this is rejected heat to the reservoir, that means this is 100. I am saying that this one is 100 divided by T1. T1 is what? This is T, because of B is received the temperature T. So this one is T. This is equation 2. Now what we have find? Eta B by eta A. Students, if I am talking about T, so basically T is what? This is the average temperature. So now we can say between A and B, between A and B, the average temperature, which is T is equals to what? This is 600 plus 100 divided by 2, that means this is 350 Kelvin. So now the value of T is 350. So here by 2 divided by 1, we can say eta B by eta A is calculated. This is 1 minus 100 divided by T is 350 divided by 1 minus T is 350 divided by 600. Now we have solved that. So this one is 350 minus 100, that means 250 divided by 350 divided by, this is 600 minus 350, that means 250. So this one is 250 divided by 600. Now 250 we have cancelled, and this is what? This is 600 divided by 350. So this one is 12 by 7. What? 12 by 7. So here the ratio of eta B by eta A is 12 by 7, which is option 3 is 12 by 7 is correct answer.
The next one is two wires of same length and material but different radii R1 and R2 are suspended from a rigid support. Both carries the same load at the lower end. Okay. The ratio of the stress developed in the second wire to that developed in the first wire. Okay, that is we have to calculate the stress in second wire upon stress in the first wire. Now both are same length and material but different radii. Material is same. So from Hooke's law, Young's modulus is equals to stress upon strain. Okay, now material is same. So Y is same for both. Y is same for both. Good. Now load is given as same. Okay, the question is like this. This is the load. Okay, so Y is equals to stress is force per unit area. And strain is, the question is asking about the ratio of the stress. Okay, but nothing has been said about the strain. Okay, they are having the same initial length. So it is delta L by L. Good. So it is FL by A into delta L. Okay. Now Y is same, load is same, length is same, area will be different. Area will be different. Okay. Rather, we should not write it as the question is asking about only about the stress produced. Y is same, strain, nothing has been mentioned about the strain. Okay, so we have to think about this strain, and the question is asking about the ratio of the stress, then there is no point of writing like this. Okay, so let's calculate the strain first, or delta L. So or delta L is equals to FL by YA. God, this is the value of delta L. That is the extension or the elongation in the wire. Okay. So, now we cannot find the relation between two different values if equation is one and there are two variables. So I think to solve this problem, we have to assume it that the extension is same. Extension is same. Okay. So y1 equal to y2. Material is same. So it is stress in 1 upon strain in 1 is equals to stress in 2 upon strain in 2. Got stress developed. Okay. Now stress is force upon area. Okay. Now there is no point we are doing unnecessarily this. Okay. Now strain is same. Okay. So stress developed will be in the ratio. So stress in 1 is load upon area. So it is, let's suppose F is the load, so pi R1 square. Okay, that is stress in 1, and stress in 2 is equals to load is F upon pi R2 square. So take the question is asking the ratio of the stress in 2 by 1. Okay, so don't divide these two. This is 1 and this is 2. Okay, the question is asking, there is no point of doing this. Okay, I don't know why so much additional information they have given. So divide 2 and 1. Okay, so it is stress in 2 upon stress in 1. Okay, so it is F upon pi R2 square upon F upon pi R1 square. F pi pi, so it is R1 by R2 whole square. Okay, R1 upon R2 whole square. So it should be square should be there in option number 2. So option number 2 is the correct answer. This is a very good question. Okay, even I was thinking, okay, because usually I didn't expect that the question will be that much simple. Okay, and it sometimes happens. We expect that this question cannot be this much simple. Okay, anyways, our answer is R1 by R2 whole square. Got, that will be the ratio of the stress developed in 2 upon stress developed in 1. Got, so option number 2 is the correct answer.
Hello dear students, let's start the problem. So the magnitude of force developed by raising the temperature from 0 degree to 100 degree of the iron bar 1 meter long and having 1 centimeter square cross sectional area, when it is held so that it is not permitted to expand or bend is. If it is not permitted to expand or bend, so what will be the what I can say that change in length will be equals to what, student? The change in length will be equals to L alpha delta T. Okay, so this will be the change in length. We can say that this will be the change in length, students, and its value will be equals to L alpha delta T. L will be equals to 1 into alpha is basically what? Alpha is given as 10 to the power minus 5 into delta T is given as what? It is 100 degrees Celsius. So what I can write is 10 to the power minus 3 is delta L. Length was already given. This is delta L. Okay. Now what I can say that if it is not permitted to expand or to bend, so there will be a force generated in the wire, or we can say rod. So the force by area stress will be developed in the rod, and this stress will be equals to half into the strain developed. The strain will only develop when it is not permitted to expand or bend. So this strain will be equal to delta L by L. So I can just write the value 10 to the power 11 multiply delta L by L is coming out is 10 to the power minus 3 by 1. So after solving this, it's 10 to the power 10 Newton by a meter square. Okay, students. So we can just write it like this: 10 to the power minus, sorry, It is 10 to the power 10, 8. So the force will come out is 10 to the power 8 multiplied by area. So the area was 1 centimeter square. So just multiply this thing. 10 to the power minus 4. So after solving this is 10 to the power 4. So force is coming out is 10 to the power 4. Option number 2 is correct. Please note it down. Thank you.
Hello students, coming to the next question. A tank whose length is 10 meter, breadth 8 meter and depth is 6 meter. So suppose if this is the tank, then this is depth is 6 meter and these two length has been given as 10 meter and this has been given as 8 meter. Right? This is the tank. This is the tank. Right? This is the tank. G is given as 10 and the density of water is given as 1000 and the thrust on the bottom. Thrust on the bottom. This is the bottom. We need to find the thrust at this surface. Now thrust is force. Force on this surface. So force will be equal to pressure into area. Force will be pressure into area. So pressure, gauge pressure at this location will be H rho G. H rho G. We will have pressure into area from this side and pressure into area from this side, or we will take the absolute pressure. Then two forces are acting for gauge pressure. This will cancel. Here pressure is P naught plus 6 rho G and here pressure is P naught times A on the either side, so this will cancel. Only remaining will be force F net is equal to pressure gauge into area. Pressure gauge is 6 rho G and area of this shaded portion will be 10 into 8. 10 into 8. So answer is 6 into 10 into 8 into rho into G. 6 into 10 into 8. 6 into 10 into 8. So first option is the answer. Thank you very much.
So in this question we are given that electric field due to an infinite non-conducting sheet of surface charge density phi at a distance r from it is. So we have to find the electric field due to a non-conducting sheet at a distance r from its surface. Okay. So let us suppose this is a infinite charge sheet like this. Okay. Now suppose a surface, Gaussian surface on this sheet. Let us say this is a Gaussian surface, a cylindrical surface, okay, like this. Okay. So if it is a thin non-conducting sheet, the direction of electric field will be like this. At this point the electric field will be like this, and here also the electric field will be like this. Okay. So if I take the area vector, see, we know that E dot ds, integral E dot ds is equal to q in upon epsilon naught. Okay, charge enclosed by the surface into epsilon naught. Now here the question says that the surface charge density is sigma. Surface charge density is sigma. So here with the reference of this cylindrical surface, if I take this cylindrical surface, the charge enclosed by this surface, if I say the surface area of this surface is S, then the charge enclosed in this surface will be equal to Q in will be equal to sigma into the surface area, that is S. This will be the charge enclosed by this surface. Okay. Now take 3 points, 3 or 4 surfaces. I will be taking 3 or 4 surfaces. First of all, say this is one surface where the area vector will be like this and S. Here the area vector is like this. Let's mark the point. This is point S1 and the surface area is constant, which is equal to S. Okay, so for all the points the surface area will remain constant, that is S, and this is S2. This is point S3 and this is point S4. Here the area vector is outward, and here the area vector is like this. Okay, so now if I talk about the integral E dot ds, see integral E dot ds also represents phi. So if I talk about flux due to surface S1 and S4, then it will be 0, because, so if I talk about the electric flux due to surface S3 and S4, then it will be 0, because the angle between electric field vector and the area vector is 90 degree. So dot product will be equal to 0. So these two surfaces have no flux. Okay, now at this surface the flux will be ES. Okay, due to the surface S1 the flux will be ES, and due to surface S4 the flux will be ES. Okay, so total integral E dot ds means the total flux, will be twice of ES, which is equal to Q in upon epsilon naught, and the value of Q in is sigma S. Then it will be sigma S upon epsilon naught. S and S goes, so E will be equal to sigma upon 2 epsilon naught. What is the value of E? That is sigma upon 2 epsilon naught. It means it is independent of the distance of the point, so it remains constant. So we can say the electric field at the point at a distance r from the sheet will be sigma upon 2 epsilon naught. Then option 1 is correct.
The next one is, a parallel plate capacitor is charged by a battery. Okay. After charging the capacitor, battery is disconnected. Battery is disconnected means Q will be constant. Always remember this. Whenever you disconnected the battery, charge will remain constant, and whenever battery remains connected, potential remains constant. Okay, here battery has been disconnected, so the charge remains constant. And a dielectric plate is inserted between the plates. Okay. Then which of the following statement is not true? Not correct. There is a N. Okay. Increase in the stored energy, decrease in the potential difference, decrease in the electric field, increase in the capacitance. Okay, not correct. We have to calculate which one is not correct. First, question is talking about the stored energy. Energy is Q square by 2C. C is equals to epsilon naught A by D. And when plates inserted, when dielectric inserted, it will be C dash, that is equals to K epsilon naught A by D. Okay, that is C increases, then U must decrease. It is saying that the stored energy will increase, but according to this, energy should decrease. So this is the wrong statement. And the question is asking not correct. So this is not correct. So option number 1 is the correct answer. We'll discuss the remaining option as well. Decrease in the potential difference. Okay, decrease in the potential difference. Now, Q equal to CV. I'm discussing option number B. And that is equal to constant. Now, as you insert the dielectric, C increases, then the potential must decrease. Potential difference must decrease. So this is correct. Correct. Okay, the question is asking not correct. This is correct. Decrease in electric field, C. Now, E is equals to V by D. D is the separation. Okay, as potential decreases, D remains same, potential decreases, so E will decrease. This is also correct. Increase in the capacitance, we have already discussed that initial capacitance was epsilon naught A by D. Now it becomes K epsilon naught A by D, and K is greater than 1 for dielectric. This is also correct. So the incorrect one is option number 1, increase in the stored energy. When you disconnected the battery and insert the capacitance, the energy stored in the capacitance decreases actually. Okay, first is the correct answer.
Hello students, so the question is, four condensers are joined as shown in the figure. The capacity of each is 8 microfarad. The equivalent capacity between point A and point B will be, okay. So we have to calculate the equivalent capacitance between point A and B. So this is point A, here the potential is A. So this is connected to a wire, so this point is also A and this point will also have potential A. This point is B, so this is also B and here also it is B. Now marking A, the potentials between point A and B. So sorry, the capacitance between point A and B. So this is AB, one capacitor. Other is between A and B, like this. Third one is also between A and B, and this is also between A and B, like this. So all the four capacitors are in parallel and everyone has each have equal capacity, okay. So the equivalent capacitance C equivalent will be given as 4 times of C, which is 4 into 8 into 10 to the power minus 6, or we can directly write it as 32 microfarad. 32 microfarad. So option 1 is correct. Thank you. Hello students, so the question is, suppose the drift velocity Vd in a material varied with applied electric field as as Vd is proportional to under root of E. Okay, see, the drift velocity is proportional to 1 by E, where E is the applied electric field, okay. Then Vi graph for a wire made of such a material is best given as, okay. So for such type of material where the drift velocity is proportional to under root of E, for that material we have to plot the Vi graph, okay. See, V is given as E into D. V is given as E into D, and I, which is current, is given as NEA into VD, NEA into VD, okay. So VD is proportional to E, VD is proportional to E, so I can write E is proportional to under root of, I is proportional to under root of E, I can write I is proportional to under root of E, and from here we can write V is proportional to E, V is proportional to E, okay. So value of under root of E is I can in a contradictory way I can say that value of E is under root of E is proportional to I, okay. So if I square on both sides, I can write I square is proportional to E, I square is proportional to E, okay. Or we can write I square is equal to some constant K into E, some constant K into E. Removing the proportionality sign, we can write some constant K into E. So equating this here, we can write V is proportional to some constant K into I square, some constant K into I square, or this can be written as V is equal to some constant K1 into K into I square, or simply V is proportional to I square. So the relation between them is parabolic, okay, parabolic relation, okay. So parabolically increasing, so option 3 is correct. Thank you. Hello students, so the question is, in a part of circuit as shown in the figure, the ratio of power dissipated by 2 ohm and 12 ohm resistor. So this is 2 ohm and this is 12 ohm resistor. Now let us assume that a current I enters the circuit and the 2 ohm and 4 ohm are in parallel, so the current will divide at this point and will divide in a ratio 1:2, okay. So 2I by 3 part of current will enter in 2 ohm and I by 3 part of the current will enter in 4 ohm, okay. So the next is power dissipated is given as I square R. So the power dissipated by 2 ohm resistor will be 2I by 3 square into 2, okay. This gives us 8I square by 9. and the power dissipated by 12 ohm resistor will be equal to I by 3 square into, sorry, the current through I, 12 ohm resistor is I, the total current will flow through 12 ohm resistor, so this will be I square into 12. So the ratio will be P2 by P12, which is 8I square by 9 into 1 upon I square into 12. Okay, so this gives us 2 and this is 3. I square and I square will cancel out. This gives us 2 upon 27, which is 2 ratio 27. 2 ratio 27. So option 1 is correct. Thank you.
The next one is 4 equal resistors are. Each are connected to form a square ABCD. One of each side, okay, one of each side is a resistor of having a resistance R. If an electric potential V is applied between the points A and B, then current flowing out of B is, that is we have to calculate the current drawn from the battery. First draw the circuit. There are 4 resistors which are represented by the sides of a square like this. Okay, this is A, B, C and D. Value of the resistors are R. Okay. Now, we have applied a potential difference between A and B, and we have to calculate the current out of B. That is current drawn, basically current drawn from the battery. Now look at the diagram. We have to calculate the equivalent resistance for this given circuit. Now if the potential is applied between these 2 points, okay, and having a potential V, okay, rather I should write it like this, V is the potential. Good. So the current I is entering and current I will enter on the next another terminal of the battery. Now it is clear that these 3 resistors are in series and the equivalent of all these 3 are in parallel with this R. So these 3 series are in parallel with this R. So by doing this we can calculate the equivalent resistance of the circuit. Once we get the value of the equivalent resistance of the circuit, just use Ohm's law, V equal to IR. We'll get the value of the current. This is how we'll proceed with the question. That is R equivalent for 2 resistors which are in parallel is R1 R2 upon R1 plus R2, and R equivalent for 2 resistors or 3 resistors are in series, then it will be R1 plus R2 plus R3 plus R4 plus R5 like this. So all these 3 are in series, so their equivalent is like this. This is B, this is A. This R, this is 3R. Okay. So RAB, that is equivalent between this A and B. Okay. That is R and 3R in parallel. So R1 R2 upon R1 plus R2. So R into 3R upon R plus 3R. That is 3R square upon 4R. This will cancel this. So RAB is equal to 3R by 4. This is the equivalent resistance of the circuit. Now the question is asking the current drawn through the battery. Okay, they have not written directly that you have to calculate the current drawn through the battery, but they have mentioned the current flowing out of B is, okay. So whatever the current out from the B and the potential difference is applied across AB, then obviously we have to calculate the current flown through the battery. So I is equal to V by R equivalent. Got it? So I is equal to V. R is 3R by 4. So I is equal to 4V by 3R. 4V by 3R, that is option number 2 is the correct answer.
Hello guys, let us solve this question. Two identically charged particles A and B initially at rest are accelerated by a common potential difference V that enters into a uniform transverse magnetic field B and describe a circular path of radius r1 and r2 respectively, then their mass ratio is, as we know, when charged particle enter in a transverse field, so here r is what? It is of under root of 2m q multiplied by v potential upon qb. Okay. Now we have to find mass ratio, and in the question accelerated with the same potential, okay, and identical charge q is same, transverse field, so r is proportional to under root m, or we may write as r is square is proportional to m. So m1 upon m2 is what? m1 upon m2 is r1 upon r2 to the whole square. So answer correct is, first answer is correct answer. It is r1 upon r2 to the whole square. Okay guys, thank you very much.
Moving to the next one, assertion. When we use new battery, it can give voltage near to its EMF. That is a correct statement, because whenever you use a new battery, its internal resistance is negligible. As time proceeds, internal resistance keeps on increasing. Okay, so if there is no internal resistance, so the voltage will be equal to EMF. Okay, so it is correct. Reason is the internal resistance of a new battery is very low. That is also the correct statement, and this is the correct explanation of the assertion. So A is true, R is true, and as you know that what is internal resistance? Internal resistance is because of the resting, because of the viscosity of the electrolytes, and as time proceeds, this keep on increasing. Okay, but initially the question is talking about new cell. There is no negligible internal resistance. So A is true, R is true, and R is the correct explanation of A. So option number 1, A and R true, R is not correct explanation of A, is wrong. A true, R false, A false, R true. Both A and R are true, and R is the correct explanation of A, that is option number 4 is the correct answer. Got it? Now move to the next one. A coil of 50 turns and 4 centimeter radius carries 2 ampere current. Then the magnetic field at the center is. Okay, let's suppose we have a coil of 1 turn. Its radius is r and carrying a current I. Then magnetic field at the center, B at the center, due to 1 turn is mu naught I upon 2r. Okay, for 1 turn. Now, not turns, 1 turn. Okay, now for n turns, B at the center will be mu naught Ni upon 2r. Now everything is given in the question, just put the value and get the answer. Okay, so B at the center is equal to mu naught is 4 pi into 10 power minus 7 into N is how much? 50. I is how much? 2 upon 2r. R is 4 centimeter, that is 4 into 10 power minus 2 meter. Okay, this 2 will cancel this 2, 4 will cancel this 4. So it becomes how much? It is this 1 0 will make minus 7 as minus 6. So it will become 5 pi into 10 power minus 6 upon 10 power minus 2. So it will become 5 pi into 10 power minus 4. Now solve this. Okay, this will be in Tesla. So it is 5 into pi is 3.14 minus 4 Tesla. It is 0 to 15, 16. So it is this test into 10 power minus 4. So it is 1.6 into 10 power minus 3 Tesla. Now it is 1.6 into 10 power minus 3 Tesla. Just look at the option. So approximately we can write it as 1.57 milli Tesla. Okay, it is actually 1.6 milli Tesla, but just look at the option. So maybe because of some approximation, we are getting this 1.6. Okay, 1.57 millitesla is the correct answer. So option number 4 is our correct answer. Got it? The next one is, a cylindrical iron core supports n turns. If a current I produces a magnetic flux phi across the cross section, then the magnetic energy is, okay, we have to calculate the magnetic energy. Now the magnetic energy through this cylindrical iron core is given by half Li square. Okay, hold it. We have to calculate half, the value of half Li square. Just look at the option, inductance is not given. Okay, no, but the flux associated with the cross section is given as phi. So the current I produces flux phi, and which is given as Li. Okay, so the value of L is equal to phi by I. Put this value of L in this equation number 1, we'll get magnetic energy as is equal to half phi by I into I square. I will cancel this I, so it comes out to be half phi I. So phi I by 2, that is option number 2 is the correct answer. This is the value of the magnetic energy as per the given condition. Got it?
Okay students, coming to the next question. A 40 ohm electrical heater is connected to a 200 volt and 50 hertz main supply. Now the find peak value of electric current flowing in the circuit is approximately, this is circuit, approximately. So now if we are talking about circuit, there is a heater which have a resistance is 40 ohm and is connected with a, which is also be called impedance, which is connected to a AC source having a voltage will be 200 volt. This is the RMS value of voltage, because of given value of voltage in a AC source will be RMS values, and the frequency F equals to 50 hertz. What? 50 hertz. Now what will you find the maximum current? So maximum current I maximum will be V maximum, what? V maximum divided by Z. Z is the impedance and the value of impedance will be 40 ohm. Now V maximum will be what? V maximum will be root 2 V RMS under root 2 V RMS divided by Z. So root 2 and V RMS is 200, that means 200, and divided by Z, Z is 40, what? 40. Now we have cancelled 0 to 0 and this one is 5, what? So maximum value of current will be 5 root 2, what? 5 root 2. And if we simplify it and find the value of approximate value of maximum current, so it will be 7 ampere, what? 7 ampere. So here we can say the maximum electric current in a heater is approximately is 7 ampere. So which option will be right? Option number 3. Thank you.
Hello students, so the question is, for a transformer the turn ratio is 3 and its efficiency is 0.75, the current flowing is in the primary coil is 2 ampere and voltage applied to it is 100 volt. Okay, so current through primary coil is 3 ampere and voltage of primary coil is 100 volt. Now the question says then voltage and current flowing through the secondary coil. Okay, now we know that NS upon NP is equal to Vs upon Vp. Vs upon Vp. Now value of this Ns is given 3, the ratio of turns. Okay, the turn ratio is 3. So Ns by Np is the turn ratio. So value of this Ns by Np is 3. So we can write Vs is equal to 3 multiplied by Vp. So 3 into 100 gives us 300 volt. Okay. Now for finding primary current, secondary current in the secondary coil, we can write eta is equal to VSIS upon VP IP. Okay, eta is equal to VSIS upon VP IP. So equating the value, eta is 0.75 equals to Vs is 300 into Is has to be calculated, Vp is 100 into 3. Okay, so this cancel out, 3 and 3 will cancel out. Is is equal to 0.75. Is is equal to 0.75. Okay. Current in the primary coil is 3 ampere. Here current is 2 ampere. Current in primary coil is 2 ampere. So this ratio will be 300 multiplied by Is divided by 100 into 2. So zeros will cancel out. We get Is equals to 1.5 divided by 3, which gives us 0.5 ampere. 0.5 ampere. Okay, so 300 and 0.5. So option 2 is correct. Thank you.
Hello everyone, the question is monochromatic light is incident at a certain angle on a equilateral triangular prism and suffers minimum deviation. If the refractive index of the material of prism is √3, then the angle of incident is what we have find, angle of incident. So the situation is, there is a equilateral triangular prism. There is a equilateral triangular prism is like this. Now there is a monochromatic light incident at an angle of I. Now it is going like that, and there is a, so we can say this is our minimum deviation. This is the minimum deviation. This one is, let this is R1, this is R2, and this is E. So in case of minimum deviation, we know that I is equals to E, and the formula of refractive index for minimum deviation, is for refracting index, refractive index is mu is equals to sine minimum deviation plus A by 2 upon sine A by 2. A is what? Prism angle, and prism angle we can say equilateral triangle we have given. So this is 60 degree. This is 60 degree. We have put all the values and find lambda m. So here the value of mu is √3 sine, value of A is what? 60. So this one is 60 plus lambda m by 2 divided by sine 30. Sine 30 is 1 by 2. So this one is √3 by 2 is equals to sine 60 plus divided by 2. So this one is 60 degree. Sine inverse √3 by 2 is 60 degree. So this one is 60 degree. Multiply by 2. This one is 60 plus lambda m. So 120 minus 60 is 60 degrees. So we can say here minimum deviation is comes 60 degree. What? Minimum deviation is 60 degree. So as we know that incident angle is also be equals to minimum deviation in case of minimum deviation. So I is comes what? This is 60 degree, that means option number 3. There is another method also. Let first of all we have say that in case of equilateral triangle, and in minimum deviation, the ray inside the prism is always parallel to the base. Is like that. So this is parallel. Okay. So we can say if this is parallel, this is 60, this one is also be 60, this is also be 60, that means R1 is what? This is 30. R1 is 30. So if I am talking about second method, so R1 is 30, I we have calculated. So we have put the Snell's law, that means 1 sine I is equals to mu sine R. R is what? This is 30. So sine I is what? This is root 3 by 2. So the value of I is what? This is 60 degree. Okay. This is the simplest method or direct. That means the answer of this question is what? Option 3, which is 60 degree.
Okay, so the question says that a point source of light is placed at a distance of 2f from a converging lens of focal length f. The intensity of the light on the other side of the lens is maximum at a distance of. So to solve this question, let us first draw the diagram. So point source of light is placed at a distance of 2f from a converging lens. So let us draw a converging lens. Let us call this a converging lens, which is a biconvex lens. And if it is having a focal length of f, I am placing an source at a distance of 2f as given in the question. Now we know whatever the light is originating from this particular source or object, this light gets converged on again at a distance of 2f, and this is the final image. So can I say the maximum intensity of the light would be the point at which the image is formed of the source, and therefore the maximum intensity would be formed at a distance of the image from the lens, which is again 2f. Now looking at the options, I would say the first option is wrong, the second is also wrong, the fourth is also wrong, but the third one is correct. Now you must try to understand the maximum intensity for a particular light source is exactly at that point. So the image formed would be the most intense part after the rays has started from this position, from the source, and reached to me. I hope you have understood this. So the final answer for this particular question is coming out as option 3, and I hope each and every one of you have understood the question as well as the concept behind this particular question and the solution and the explanation provided to you. Thank you.
Moving to the next one. In an interference experiment, two parallel vertical slits S1 and S2 are used. That is, question is talking about Young's double slit experiment. A thin glass plate is introduced in the path of light from S1. Then, just look at the option, fringe pattern remains unaltered. Second is fringe pattern as a whole is laterally shift towards S1. Third is fringe pattern as a whole is laterally shift towards S2. Fourth is fringe width decreases. Okay, now the experimental setup is like this. S1 and S2 are two slits, and this is screen. Okay, now according to the question, you have placed a glass plate in front of S1. Now, in front of S1. Okay, here you have placed a glass plate. Now, according to YDSC, that is Young's double slit experiment, if a sheet has been placed in front of a slit, then the whole pattern of the whole interfering pattern shift towards that side where you have placed the sheet, that is towards S1. So this is initially the central bright fringe, central bright. Okay, now the whole pattern will shift towards S1, that is in the upward direction. S1 doesn't mean that the pattern will shift here like this. No. We are observing the interference in light, and obviously interference in light will observe on screen. So it will shift towards upward direction. Got it? So the pattern will shift laterally towards S1. So option number 2 is the correct one. Now the fourth, let's discuss option number 4 also. Fringe width beta is equals to lambda d by d. Lambda is the wavelength of the light used, d is the distance between slit and the screen, and small d is distance between the slits. Now as the distance between the slits remains unchanged, because by placing a glass plate in front of S1, this distance remains unchanged, so the beta will remain constant. This is wrong. So option number 2 is the correct answer. Now move to the next one. A ray of unpolarized light is incident on glass plate at the polarizing angle. Okay, that is, this is unpolarized light. This is unpolarized light and it incident on a glass slab at polarizing angle. Okay, then reflected ray and transmitted ray will be completely plane polarized is incorrect, because in this case this is reflected, this is completely polarized, and this is partially refracted is partially polarized. Reflected ray is completely polarized and the transmitted ray is partially polarized. It is the correct statement. We'll also try for option number 3rd and 4th. The reflected ray is completely polarized and the transmitted ray is completely polarized. It is incorrect. The reflected ray and the transmitted ray will be partially polarized is incorrect. Here CP is completely polarized and PP is partially polarized. That is option number 2 is our correct answer.
Hello guys, let us solve this question. Which of the following statement is correct regarding to photoelectric effect? Okay, now first statement is the photocurrent increases with increase in intensity. Yes, here intensity is what? Intensity is equal to energy per unit area per unit time, energy that is energy of photons. So number of photon whenever increases, so intensity will be increases, and current is proportional to intensity. Whenever intensity increases, then photocurrent will also be increases. So first is correct option. Now the stopping potential increases with the increase in intensity. No, stopping potential is not depend on intensity. Okay guys, the photocurrent increases with increase in frequency. No, photocurrent is depend only on intensity. Okay, so first option is the correct option. Photocurrent increases when the intensity will be increases. Okay, thank you very much.
Now moving to the next one. A photon of energy h mu is absorbed by a free electron of a metal having a work function W, and W is less than h mu. Then electron is sure to come out. Either electron does not come out or it will come out with kinetic energy h mu minus W. It may come out with kinetic energy less than or equal to h mu minus W is the correct answer. Okay, electron is sure to come out with the kinetic energy h mu minus W. No, it's not like this. So it may come out with the kinetic energy less than or equal to h mu minus W. How come? Okay, so this is a metallic surface. H mu energy comes. W is the work function. Now photoelectrons emitted with the energy, let's suppose kinetic energy K. So from Einstein equation, H mu is equals to work function plus K plus heat. Now if heat is zero, then H mu is equals to work function plus K max. So H mu minus W is equals to maximum kinetic energy, not the kinetic energy of every electron. Actually, when photons come, according to Einstein, one photons interact with one electron and one photons collide with one electron elastically, and during that one collision, it transfers complete energy to the electron. Okay. So all the electrons come out with a different kinetic energy that can have any value from 0 to a maximum value. Okay. So it may come out with the kinetic energy less than or maximum equal to h mu minus W. Option number 3rd is the correct answer. A very good question. The next one is, the ratio of ionization energy of Bohr's hydrogen atom and Bohr's hydrogen like lithium ion is. Okay, we have to calculate the ratio of the ionization energy of Bohr's hydrogen atom and Bohr's hydrogen like lithium ion. Bohr's atomic model is valid for hydrogen and hydrogen like elements. Okay, so question is asking about the ionization energy, that is the energy required to take an electron from the ground state. Okay, so that the atom will be ionized. Okay, so energy of electron in ground state for hydrogen like element, and that is equals to, this energy is equals to minus 13.6 Z square electron volt. Okay, so the ionization energy, so ionization energy is given by 13.6 Z square eV. Okay, so for hydrogen atom, okay, we have to calculate E for H is equals to 13.6. The value of Z for hydrogen, that is Z is equals to 1 square first. Now for lithium, Z is equals to 3. Got it? So E for lithium is 13.6 into 3 square. Got it? Question is asking the ratio of the ionization energy, that is E of H upon E of lithium, that is 1 square by 3 square, that is 1 by 9. So the ratio of the ionization energy for hydrogen and hydrogen like lithium is 1 by 9, that is option number 3rd is the correct answer. Now moving to the next one. On the basis of Bohr's atomic model, the radius of third orbit of any atom is 3 times that of first orbit, 9 times that of first orbit, 1/3 of that of first orbit, equal to the radius of the first orbit. So from Bohr's atomic model, a radius of nth orbit is directly proportional to number of orbit square upon atomic number. So for n equal to 3, third orbit, so r directly proportional, r comes out to be how much? 3 square is 9. So the radius will be 9 times of the radius of the first orbit. Option number 2 is the correct answer. Got it? Now moving to the next one. A radioactive nucleus undergoes a series of decay according to the scheme. Okay. First alpha, then beta negative, then alpha, then gamma. Okay. If the mass number and the atomic number of A are 180 and 72 respectively, then what are these number of A4? Okay. That is, we have to calculate the mass number and atomic number of A4. Okay. So starting with A. Mass number 180, atomic number 72. Now alpha decay. Mass number decreased by 4. Okay, so A1. Mass number decreased by 4. So it will be 176. And the atomic number decreased by 2. So it is 70. Then beta negative decay. Beta negative. Mass number remains same, but atomic number increases by 1, so it is 71. Okay, then again alpha decay, mass number will again decreases by 4, so A3 decreased by 4, so 176 decreased by 4, it is 172, and atomic number decreased by 2, that is 69, okay. And then in gamma decay, mass number and atomic number both remain same. So it is 172 and 69. So mass number and atomic number of A4 is 172 and 69 respectively. 172 and 69, that is option number 3rd is the correct answer. Got it?
Hello guys, let us solve this question. In a PN junction diode not connected to any circuit. This one is PN junction. This one is PN junction. Okay. And this one is deflection layer. Now, in P part, it is of immovable negative ions with hole. And on deflection layer, this one is negative. And in N part, this one is positive. Okay. So, an electric field from positive to negative whenever no biasing, no battery is connected with the diode. Okay. In N part, it is positive, immovable with free electrons. Okay. And this structure is PN junction. Now, first one is the potential is same everywhere. No. Potential here is the potential barrier. So, first is not correct. There is, second one is the P type is a higher potential. Now, P type at lower potential. So, second is also incorrect. There is an electric field at the junction field, that is junction field. Okay, directed from the N to P. Yes, N to P. This one is correct. There is an electric field at the junction direct from P to N. This one is also be incorrect. So, correct option will be third option. There is a electric field at the junction electric field from N to P. Okay guys, thank you very much.
Now moving to the next one, the combination of the gates shown below produces. Okay, these are 1, 2, 3, 4, 4 gates, and the question is asking how the combination behaves like. Okay, so this is A, so it will be A bar. B, not because of not, this is B bar. Here it will reach as A bar, B bar, whole bar. Okay, let be C, and again a not gate, so it will be C bar. So output is C bar. Okay, this is clear. A bar here, B bar here. It will be A bar, B bar, whole bar. So A bar, B bar, whole bar is A bar not vector, okay, plus B bar. You are getting this. This will behave like this. Okay, and the output is C dash. Output is C dash. Okay, so this because of this bar, whole bar, so it will be A plus B. Okay, this is the value of C. So the final output is C bar, that is equals to A plus B bar. Okay, so this will behave as NOR gate. Okay, like NOR gate. Okay, like this. So it will be C bar and it is A plus B whole bar, which is NOR gate. Option number 3rd is the correct answer. Now moving to the next one, the given plot represent IV characteristics for a semiconductor device. IV characteristic for a semiconductor device. Which of the following statement is correct? It is IV characteristic for solar cell. IV characteristic for photodiode connected in forward bias is wrong. IV characteristic of LED in a forward bias, no. It is clearly a reverse biased. Okay. So it is IV characteristic for a photodiode connected in reverse bias. That is correct. First of all, photodiode always connected in reverse biased. Okay. And reverse biased, current versus voltage graph is like this. Like this. This is forward biased. This is reverse biased. Okay. And for photodiodes, okay, I versus V graph is like this. Like this. Okay, which is this one. So it is IV characteristics of photodiodes connected in reverse bias. Option number 4 is the correct answer. Got it?
Okay, so the question says that a magnetic needle lying parallel to a magnetic field requires W units of work to turn through 60 degree. So initially the magnetic needle is lying parallel to magnetic field. That means the value of M and B are aligned in the same direction. So can I say the work done W is equal to U2 minus of U1. That means what? That means minus of MB times cos of 60 minus of MB times cos of 0, and this comes out to be, now cos of 60 is actually half, so this is coming out as MB by 2 is equal to W. Now once you have understood this, the external torque required to maintain the magnetic needle in this position is, so at this particular moment we need to calculate the value of external torque. So torque, as we know, is given as M cross B, and the magnitude would be given as MB sine of 60 degree, which is coming out as root 3 by 2 into MB, which finally comes out as W root 3. So the final answer for this particular question is coming out as W root 3, and let us now match the answer that we have got with the options given in the question. Looking at it, the first is wrong, the second is wrong, the third is wrong, and the fourth one is correct, and hence the final answer for this particular question comes out as option 4. I hope each and every one of you have understood the question as well as the concept behind this particular question and the solution and the explanation provided to you. Thank you.
Welcome students, coming to the next question. A steel wire of length L and magnetic moment M. So this is a steel wire whose length is L and magnetic moment is M. Pole strength is plus M minus M, and we can say M is small m times L. Now this is bent in L shaped. This is bent in L shaped at midpoint. So here will be, so we have two magnets of length L by 2. Magnetic moment here will be M by 2, as M by 2 is equal to M times L by 2. So we have two magnets whose magnetic moment is M by 2 and M by 2. From triangle law of vector addition, this will be the resultant. This will be the resultant magnetic moment. And we will find using simple Pythagoras theorem, M by 2 whole square plus M by 2 whole square root under, this will be length of this line, or resultant can also be found out using vector parallelogram law of vector addition, a square plus b square plus 2ab cos theta. Theta here is 90 because it is perpendicular, and cos 90 is 0. So this will become root 2 times M by 2. So M by root 2 is the new magnetic moment when this is bent in this way. Thank you.
Okay, so the question says that magnetic susceptibility is small and negative. Now magnetic susceptibility means negative. It implies that the magnetic field lines are repelled by the substance, and this repellation only occurs in one type of a material out of the total 3, and that type of a material is called as a diamagnetic substance. So looking at the options, diamagnetic substance becomes correct and all the other options becomes wrong. So the final answer for this particular question comes out as option 1, and I hope each and every one of you have understood this. Thank you.
Students, moving to next question. This problem is based on match the column. We have two lists, list 1 and list 2. List 1 is all about the electromagnetic wave type. Electromagnetic wave type means if you see electromagnetic spectrum, let us draw. The first one is coming as microwave. Okay, let me draw in a vertical column. Why? Because space is not there. Okay, the first one is microwave. After that, radio wave is coming. Then infrared. Okay, after that VIBGYOR is coming. So we are writing as visible light, VIBGYOR. And after visible light we have ultraviolet, then X-rays. After this gamma rays is coming. Okay, if you are going in this way, we have wavelength decreasing and frequency increasing. if you are going down, the wavelength is decreasing and frequency is increasing. So let us see, we have electromagnetic wave type, this is electromagnetic spectrum, and list 2 contains application, means the usage part. Select the correct option from the choices given below the list. Okay, infrared wave, okay, this can be used to treat muscular strain. Yes, in medical science this is the usage of infrared wave. Radio waves, as the name suggests, okay, radio is a device used for communication, so it is used for communication purpose. It is used in communication. For broadcasting, yes, this is the correct one. Broadcasting means communication. X-rays, the wavelength of X-ray is important, and if you know the wavelength, then only we can answer. So for X-rays, okay, we are writing lambda of X-rays is of the order of interspace of atoms. What is meaning of this interspace of atoms? Okay, X-ray is also chapter in modern physics. Okay, so from that also you must know how the wavelength varies. It is from 0.1 angstrom to 100 angstrom. Okay, this is one way. Another way, it is of the order of interspace of atoms. Suppose some crystal is there, okay, bone is there, or any crystal structure is there. This gap, these two are the atoms. The gap between two atoms is interspace. Okay, space means vacuum and inter means between two different quantities. So this gap is called as interspace of atom, and this is of the order of lambda of X-rays. Okay, students, so because of this lambda, it is used to detect fracture of bones, and some phenomena we are using, that is a process of detection. For UV rays, okay, it is used to kill bacteria also. Many applications are there. Okay, ultraviolet rays is used to kill bacteria in medical science. In AquaGuard like devices also UV ray protection is there. Okay, here they are writing absorbed by the ozone layer of the atmosphere. Yes, UV rays is emitted by sun rays. Okay, sun rays contain UV rays. So that UV rays is absorbed by the ozone layer. So yes, correct matching is A1, B2, C3, D4. A1, B2, C3, D4. Correct answer is option 4th one.
The next one is a parallel plate capacitor with plate area 2A and a separation between the plates D is charged by a constant current I. Okay. Consider a plane surface of area A by 4 parallel to the plates and drawn symmetrically between the plates. Okay. What is the displacement current through this area? What is the displacement current through this area? Which area? A by 4. Okay. And you are charging the capacitor by a current I. And the question is asking about the displacement current. Okay. Displacement current. That is ID. And that is equal to I. Okay. You are charging this capacitor by a current I. And you have to calculate the displacement current through this area A by 4. So current into area, because this current will be uniformly divided. Okay, distributed, not divided, distributed in an area of, what is the area of the plate is 2A. So divided by 2A. That is the displacement current. Okay, that is the displacement current through this area. Okay, so it is I A by 4 into 2A. So A will cancel this A and the displacement current comes out to be I by 8. I by 8. Okay, that is option number 4th is the correct answer. Option number 4th. Got it? This is the expression of the displacement current for this area. Got it?